Find the exact value for the expression tangent negative 2 pi thirds. Starting off with, where is negative 2 pi thirds? Pi thirds negative 1, 2. That is negative 2 pi thirds, giving us a reference angle of pi thirds and a quadrant 3. Now, all students take calculus tell us that tangent and its reciprocal cotangent are positive in quadrant 3. So we're after tangent, it's positive. So our answer is positive. Now, what is tangent of the reference angle pi thirds? Tangent is sine over cosine. Sine of pi thirds is the square root of 3 over 2, and cosine is 1 over 2, and the 2's cancel. The square root of 3 over 1, or square root of 3. And that's all there is to it. Make sure that you are doing a two-step process. Step 1, find the reference angle so that you can figure out the value, in this case square root of 3. Step 2, find the quadrant of the terminal side, in this case quadrant 3, where tangent's positive, to get our plus. Find the exact value of cotangent 3 pi fourths. First off, 3 pi fourths. Pi fourths, 1, 2, 3. This is 3 pi fourths. This gives us the fact that we have a reference angle of pi fourths, and it also gives us the fact that we're in quadrant 2, where all students, sine is the only positive. Since sine is the only positive one, and its reciprocal cosecant, the fact that we're looking for cotangent means we're going to find a negative answer. So our answer is negative. Now, cotangent is cosine over sine. We need to find cotangent of pi fourths. Cosine of pi fourths is square root of 2 over 2. Sine of pi fourths is square root of 2 over 2. So cotangent of cosine over sine would be 1. And this completes this problem. Use a calculator to find the function value to 4 decimal places. Cotangent 4.32. Notice, no degree symbol. So take a moment and get your calculator in radian mode. Mine is all set. And we do not have a cotangent button on our calculator, so we think the tangent instead. Tangent 4.32. Now our calculator, we can work out tangent of 4.32 easy enough. It gives us 2.4163326, etc. There's a lot more information, and I'm not ready to round yet because I'm not on my final answer of cotangent. Now, do not clear your calculator. There's either a button, a 1 over x button on your calculator, or maybe it's a button x to the minus 1, or you could just do divide, let's see, 1 divided by the button answer button. You might have an answer button as well. Any of these three will flip your answer. So whatever button you do, flip your answer so you can get to the cotangent 4.32. And when I flip this, I get 0.413850, etc. And they want 4 decimal places. So we go to the 4th decimal place, and notice the 5 will push it up. So our final answer would be 0.4139. And that's how you do it. Determine the period of the function. Y equals cotangent 13 pi fourths. To find the period, basically the formula is the period equals the usual period divided by the coefficient of x. Okay, now as I look at this problem, I realize there is something wrong here. There's no x. Because there's no x, there is no period to this function, because this is not a periodic function. So we are going to have to assume that there was an x there. Okay, with that in place, what we would do is take the usual period. The usual period for tangent and cotangent is pi. The coefficient of x is 13 pi fourths. Now you can take this and multiply by its reciprocal and get the pi's to reduce and have 4/13, which would be the period of this. Now you will notice if you look at the answers, they have 1. They have, I don't know where they got their answer, because this question, I don't even know where they got this question. This was not a good question. But if it had the x, this is an easy enough question, and hopefully that helps you out. Graph the function y equals 1/3 tangent parenthesis 3/5 x plus pi fifths. First off, this is not in standard form because of the 3/5 is not factored out. So we'd start off by factoring out 3/5 and getting, 3/5 times x, parenthesis, x plus. When you factor out 3/5, you're actually multiplying by 5/3, and the 5's would cancel and you get pi thirds. Okay, great. So this tells us a couple of things. First off, the period is usually 2 pi over, 2 pi for sine and cosine. It's pi, the regular period, divided by the coefficient of x, in this case 3/5. That gives us 5 pi thirds. So the period's 5 pi thirds. The phase shift is negative pi thirds. This one moves left pi thirds. Now, normally a tangent, you'll go left pi halves and right pi halves and find an asymptote. And 0 would be where it crosses, and then it would increase. Negative pi halves and pi halves. That's the normal situation. So it usually crosses right at the origin. In our case, we have a phase shift, so it's going to cross left pi thirds. So I'm going to go left pi thirds. So there we are, left pi thirds. That's where it's going to cross. Now, the period, with a tangent, you go half of the period to the right and half of the period to the left to find these two asymptotes. So half of the period. With our period of 5 pi thirds, half of that's 5 pi sixths, which is not very nice. Maybe we do it this way. 5 pi thirds, 1, 2, 3, 4, 5. Half of that distance is about here. 5 pi 6, or 1, 2, 3, 4, 5 pi 6. Whoa, here we go. Oops, grab a color. That's our asymptote. So with 5 pi 6, half of this period to the right, then if I go half of that to the left, then the distance between these asymptotes will be 5 pi thirds, the period. So each mark is a pi thirds, so each half mark would be a pi sixths. So left 5 pi sixths. 1, 2, 3, 4, 3, 4, 5, right there. Again, 1, 2, 3, 4, 5. So that's our spot. Now we have our asymptotes. These asymptotes are a width 5 pi thirds, and they're shifted left pi thirds from where they normally would be. Now the last thing to look at, normally tangent goes up. We have a 1/3 coefficient. It's positive, so this will still go up. Usually go over 1 from there and up 1. This one's going to go like over 1 and up a third, so this one's going to be a little bit fatter. But that 1/3, what's the most important about that 1/3 is the fact that it's positive, so it's going to increase. All right, that was a fair amount of work to get 1 period. I'm glad they didn't ask for 2. Graph y equals 2/3 cotangent parenthesis 2/5 x plus pi halves. So cotangent. The regular cotangent, just cotangent x, it has an asymptote at 0. And if you go over the period of pi, it has another asymptote. halfway in between there, it's at 0, and it's a decreasing function. So that's what the normal cotangent function looks like. We need to figure out what this one does compared to that. Now notice it's not in standard form because the 2/5 is not factored. So that's going to be something I do right off the bat. 2/3 cotangent of 2/5 times, now when you factor out 2/5, you're multiplying by 5/2. So we'll get 5/4 plus 5/4. I'm running out of, there we go. That's our standard form. So that tells me a couple of things. The period is the normal period of pi divided by the coefficient 2/5. That would be 5/2. Our period is 5/2. The phase shift is negative 5/4, and that's the reason why we factored out the 2/5 to easily see the phase shift. Okay, now our normal asymptote is at 0. Normally it's at 0. In this case it's at negative 5/4 because we went left 5/4. So that's a full pi and another fourth. Full pi and another fourth. So that puts us about right here. Alright, now the period is 5/2. So I need to move right 5/2 of this asymptote to find my next asymptote. So minus 5/4 plus 5/2 is 5/4, I believe. Yes, it is 5/4. So it's actually the same distance on the other side, a little over pi. Now what we'll have, and you want to verify, is this distance is the period of 5/2. Since we went left 5/4 and we go right 5/4, that'll be 5/2. So the phase shift is making this look more like a tangent, but it's a cotangent. Now cotangent in the middle is usually right here. You might have like a +4, and this thing would be up 4. But since we don't have a plus or minus outside of here, it's still at 0. It's still, in the middle. So in the middle of these two asymptotes, it's at 0. And it's normally a decreasing function. That is, if the coefficient is positive, this will be a decreasing function. We do have a coefficient is positive, so this will be a decreasing function. So we can now sketch a decreasing function through there, and that completes this picture. Find the equation for the curve in its final position. The graph of y equals cotangent x is shifted a distance of pi/2 to the left, reflected in the x-axis, then translated 7 units upward. So there are 3 things, 1, 2, and 3. And we're going to track each one at a time. So we'll start off with y equals cotangent of x. Number 1, shifted pi/2 to the left. That will change it to y equals cotangent of x minus pi/2. But that's to the right, x plus pi/2. We'll move it to the left. Okay, the second, reflected in the x direct axis changes the whole function. To x-axis reflection, you change the y value. So this will change the whole function on the right to y minus cotangent of x plus pi/2. And that just simplifies. So we have y equals negative cotangent of x plus pi/2. All right. And then the third thing, shifted 7 units upward. We have negative cotangent of x plus pi/2. Shifting up just is +7. And that would be your final answer. And that completes this problem.